As the effects of climate change escalate, organizations around the world are racing to reach net zero emissions targets, and cleaner energy is helping to power that push. Today, we're looking at the future-focused energy initiatives and innovations that are aiming to turn net zero ambitions into reality. In today's fast-paced and complex business landscape, project professionals lead the way, delivering value while tackling critical challenges and embracing innovative ways of working. On Projectified, we bring you insights from the project management community to help you thrive in this evolving world of work through real-world stories and strategies, inspiring you to advance your career and make a positive impact. This is Projectified. I'm Steve Hendershot. The relentless pursuit of clean and affordable energy requires a massive global commitment, and organizations are stepping up, investing $2 trillion annually in new technology to accelerate the clean energy transition, according to the International Energy Agency. That's a serious boost for project teams as they implement emerging tech, such as artificial intelligence or smart grid platforms, to supercharge their clean energy efforts. Today, we're speaking to project leaders at the forefront of the clean energy transition. We'll start with Gary Archer, Director of Performance and Sustainability at OneSubsea, a joint venture backed by energy giant SLB and other partners. He's based in Houston. We spoke with Gary about new ways the fossil fuel industry can minimize its environmental impact. Thanks for chatting with us, Gary. Let's start with the transition to cleaner energy and global efforts to achieve net zero emissions. What's behind this push, and how do different forces come together to affect practice?
Yeah, thanks, Steve. Let's start by framing the problem. Global warming is a reality, and the main driver of this is greenhouse gas emissions from burning fuels. And in terms of the big industrial drivers behind these emissions, oil and gas extraction, the supply of these fuels to power the world, is itself one of the largest emitters. And there are, of course, many others, sectors like agriculture, retail, transportation, construction. The good news is that we all know the solutions to the problem, and it lies within the United Nations Framework Convention on Climate Change. This is the pathway to reducing global warming by curbing those greenhouse gas emissions. And then kind of wrapped around that and binding it all together is the UN's Sustainable Development Goals. And it's fair to say that there's universal buy-in to these frameworks and agreements. In fact, at the most recent UN Climate Change Conference, 50 of the world's top oil and gas producers committed to being net zero by 2050 and to pretty much eliminate methane emissions by 2030, which is a very significant commitment. So what makes the subject so complicated? Well, to contextualize that, the world's population is rising, and that means global demand for energy continues to grow. And some of that growth is in parts of the world where emissions are traditionally higher, heavy dependency on fossil fuels, less so on renewables. And if we overlay that against the need to slow global warming and cut GHG emissions, plus the complex geopolitical landscape, the real scale of this challenge starts to emerge. And we refer to this as the energy trilemma. So I think most of your listeners will be familiar with the concept of triple constraint in project management. You need to juggle your scope, your schedule, your cost, three interdependent factors, and you can't really change one without influencing at least one of the others. You can think about the energy trilemma in the same way, but the constraints are security, affordability, and sustainability. So what our world needs to continue powering the growth is abundant energy that's secure, affordable, and low carbon. Our technology innovation is focused around decarbonizing our customers' operations by moving that factory to the seabed to produce oil and gas from subsea reservoirs, which has some of the lowest development costs and the lowest carbon emissions in the industry.
What are some of the types of new technologies that your teams are implementing to achieve those goals?
Let's first consider the philosophy that if we take oil and gas production and processing equipment that traditionally speaking is located at the surface in a production facility, whether that's offshore or onshore, and we move this down to the seabed, it does a few things. by locating these processes closer to the production stream itself, it's just inherently more efficient and less power intensive. And it also opens up additional opportunities to increase, for example, the electrification of that equipment and the use of unmanned facilities. So we can take substantial amounts of infrastructure and human intervention out of the processes. I mean, obviously that's good for process safety as well as sustainability, of course. And then consider that you can produce a subsea reservoir more efficiently that way, a higher recovery factor, and prolonging the peak phase of production with much lower energy consumption. So this really starts to move the needle on both field economics and sustainability aspects. An average surface production development will generate around 19 kilos of carbon per barrel of oil equivalent. An equivalent subsea gas development with current technology and electrification can be as low as 7 kilos. So quite a step change.
In terms of processes, operational changes, anything you're able to do there to move the sustainability needle?
What we wanted at OneSubsea is for sustainability to be embedded truly into our systems and processes. So when we considered this within the organizational design, we put both of our sustainability team and our project management office, our PMO, side by side under a function that we call performance and sustainability. So this allows us to take the key objectives from our sustainability agenda and embed it straight into our project execution model. We have process steps to make sure that sustainability is a living and breathing part of the entire project life cycle, you could say. In the earliest phase of engineering design, we're able to quantify the embodied carbon and the life cycle emissions of our product. Through our planning tools, we can then run multiple iterations of field layouts, which allows us, obviously in collaboration with our customer, to optimize the system design for maximum efficiency and sustainability. I mean, our sustainability agenda itself is very aligned to the UN Sustainable Development Goals. So by embedding sustainability into our project processes, it's our mechanism for staying aligned to our key objectives and also aligning with the greater needs of society as we help our customers to decarbonize their operations whilst we also decarbonize ours.
Is there a case study we could get a little deeper on, more specific, where you've been able to dig into an oil and gas undersea project and facilitate more sustainable operation than a client was able to achieve otherwise?
Yeah, this is the really good stuff now. So I've got two examples in particular. The first one involves the revitalization of a subsea field that was already halfway through its life cycle. This field feeds gas from Norway to the UK, and at its peak times actually represents around 20% of the UK's entire gas consumption. Due to a natural decline in the reservoir pressure from these wells, the production rates were starting to go down to around half of their peak levels. So in collaboration with that particular client, we performed a study to look at the impact of using subsea gas compression in order to boost the recovery from these wells. And what we found is that subsea compression could be achieved with less than 50% of the footprint of a traditional topside platform-based compression system, enable a substantially better production profile for the wells, and with less than half of the energy consumption to power that system. And that energy itself comes from low-carbon, renewable electricity fed from shore, which is 120 kilometers away. This system comes online very soon, and it's expected to deliver around a 30% increase in production of some of the lowest carbon energy in the whole industry. So, massive step change in efficiency. The next example is the fast-track development of a gas field in the Black Sea. A typical gas field development can take anywhere between, say, 4 to 6 years to develop, considering the need to build out infrastructure both onshore and subsea. So when our client explained their objective to deliver gas from subsea wells to the electrical grid in less than 2.5 years, we had to get pretty creative. Looking at a waterfall schedule running out 4 to 5 years just wasn't going to work. And the way we met the client's objective was through a combination of a few things. We leaned into standard equipment designs in order to fast-track the engineering and procurement phases. These are also some of our lowest carbon products that are highly value engineered for sustainability. We used adaptive project management techniques so we could execute multiple work streams in parallel. And given the interdependency between some of these activities, that meant staying really laser focused on risk management and change control. And perhaps most importantly, we integrated our technology offering across the full portfolio of products from OneSubsea, from our parent SLB, and our consortium partners to deliver a comprehensive solution. Our technology was seamlessly integrated from the reservoir all the way through a production system and into the onshore facility, which was an industry first, actually, for a client to procure a fully integrated EPCI solution from one supplier from reservoir to grid. By leveraging the real breadth of the technology portfolio, we delivered a true fast-track outcome.
What skills help you the most in delivering these tech-forward energy efficiency projects? And what skills would you recommend professionals develop to do the same?
I believe we need to recognize that the scale of the challenges posed by the energy trilemma can't be solved in isolation. It really requires a coordinated effort across the entire value chain, and this needs collaboration. Collaborating with customers allows us to unlock new ways of working, allows them to make marginal projects viable through more efficient solutions, decarbonizing operations through novel technologies as well, and to make project execution more seamless through digital collaboration tools, for example, and having a real one-team approach. Taking that same collaborative approach into our supply chain, I believe we're able to harness experience and innovation from our suppliers, while at the same time we can share our best practice and help our suppliers to become better together with us. And increasing transparency in relationships isn't always a comfortable thing to do inside the traditional procurement models within our industry. So it does also call for innovation in respect of alliancing and, alternative commercial models too. I'd say innovation is also critical, both from a technology and an execution standpoint. Where needles are there to be moved, they need to be moved. And from an economical and sustainability standpoint, where the big gains have already been realized, I think it's also important to keep seeking out the smaller incremental gains. A mindset of being creative, challenging the status quo, having the courage to keep on asking why not. Many examples I've highlighted today are actually the product of having great engineers and project managers changing paradigms to deliver better solutions, quicker, lower risk, lighter footprint. And that's truly born out of innovation. I'd say a final point, Steve, on skills would be creating a culture and a mindset around learning and continuous improvement. If we're constantly learning and adapting our approach, and if we create the right feedback mechanisms in our business, then our technology, our systems, and our processes all stay relevant and fit for purpose together.
I want to close with this question. What do you find meaningful about this work? What effect do you hope your team's work and your work will have?
For me, it's quite simple. The energy industry is facing its biggest ever challenge with the energy trilemma. It's more in the spotlight probably than it ever has been before. I'm a project manager at heart, and my job in this world is to solve complex problems, and this is probably one of the most complex that's going. I feel genuinely lucky to arrive at work every day thinking about how we can deliver better projects that create benefits for everybody, including a cleaner planet for us to hand over to our kids and our grandkids. Decarbonising our industry and making subsea developments really resilient and compelling investment decision for our customers. I think it does good for the energy mix and good for planet Earth.
Really quick, are you enjoying this episode? Leave us a rating or review on Apple Podcasts, Spotify, or wherever you listen. Your feedback helps us keep making this show. Okay, let's go to our next conversation. One of the hurdles to the clean energy transition is making sure the grid can handle renewable sources. In fact, a report from Institutional Shareholder Services says grid bottlenecks are one of the most significant challenges today's teams face. Our next guest knows all about this. Tiago Vronsky is an engineering and technical support director at electric power giant GE Vernova. He's in São José dos Campos, Brazil. He told Projectified's Hannah LaBelle how his teams implement digital solutions to provide an uninterrupted flow of clean energy.
Tiago, it's great to speak with you. Let's start by discussing the projects you and your teams are working on. What's the focus of your work?
Most of the projects today, Hannah, we integrate clean source of energy to the grid. A wind farm, it generates energy. Generation is not enough, it's just a part of the equation. We need to take that generation and find ways to deliver that energy to the final consumers, like industry, like homes. At Grid Automation, our business will take care of this transportation, so plugging the energy source to the grid and transporting it to the final customer.
What types of new technologies are your teams using on projects to help kind of incorporate these cleaner energy sources into the grids that customers are using?
Our technology is really related to the grid. I would say in general terms, we are focusing a lot on digitalization. In the electrical substation level, we have what we call the digital substations. Electrical substations is the main part component of electrical grid, are the nodes of these electrical grids, and we are trying to digitalize it the most that we can, replacing hardware for software assets and implementing the flexibility and changeability that the software provides us. But most importantly, we are doing a lot of things at the grid level. And when we look at the grid level, I can have a set of substations that take care for New York State, for example, in US, or California. So we take a look at technologies to make all these grid or microgrid reliable. And we call it advanced automation applications. And what is it? This is kind of a solution that are software-based, and they aim to guarantee the stability and reliability of the grid at a higher level than the substation level itself. For example, we use that to avoid the blackouts. Okay, we can have a severe weather condition. It may disrupt the electrical grid, but we want to make it reliable. So this advanced automation takes care of these unexpected events and maintain the stability of the grid. So this is very important. Besides that, we have some technologies also for post-operation, maintenance and asset management technology that we do data analytics to understand how my fleet of equipment, my assets are performed, like preventive maintenance, risk avoidance of disruption because of equipment conditions. And we have also cutting-edge technology, which has the PMUs that we are using. PMUs is phasor measurement units, which is used like a high-precision grid data collection. We collect two electrical quantities that are voltage and current. These PMUs, they allow us to collect that information in like a microsecond rate, and then we have really a good understanding of how the grid is performing. Based on that, we can adjust our protection and control systems, and we can work with national operators, governments, to make plans of how to expand the grid, how to change it in order to meet our goals. And just to finalize, these equipments are connected, so there is a risk on that, which is cybersecurity. And that's very important in the critical infrastructure sector, like electrical energy generation. So we are developing a lot of technologies also to make all our solutions safe in terms of cybersecurity threats.
Let's walk through one of your projects. Tell us, what is the project's goal and how is it benefiting the customers that are going to be using the energy from the grid and the planet?
A very important project for us here is called Itaipu. It is an ongoing project. In fact, it's a project that is going to last 14 years, and we have 12 years to go. It is a modernization of an existing hydropower plant. It generates nearly 90,000 gigawatt hour per year, okay? And to put that number in context, Hannah, if you take only home consumption, this amount of energy could supply electricity for around 40 million homes, that would impact more or less 140 million people. Okay? So it's huge. The GE Vernova has been awarded a contract to deliver what is called the technological update of the power plant, and its electrical substation is 40 years old. It's becoming obsolete, and that's the importance because we want to keep it running because of the impact.
So what tech is involved in this power plant upgrade?
We have the digitalization of a control system. We have advanced communication networks to give reliability and easiness in the operation and maintenance, not only for the power plant itself, but also to the substation that plugs that power plant at the grid. And we are applying a strong, very strong cybersecurity network and cybersecurity measures because this is really a critical infrastructure.
What are some of the challenges that you think might come up during this process, given all of these different technologies and the different areas that you're focused on?
One of the biggest challenges are customer requirements, okay, in terms of project management. Itaipu is a binational power plant, half Brazil and half Paraguay. First of all, it's two languages. Okay, in Brazil, we speak Portuguese. In Paraguay, they speak Spanish. So we have requirements for Brazilian government. We have requirements for Paraguay government. And in terms of technology, Hannah, Itaipu, they push the most that they can, the latest technology. So we have a lot of requirements that are very specific. We also had to bring more technology to our solution to meet those requirements, which is, at the end of the day, is very good because we can use those enhancements in other projects worldwide.
How does that 14-year timeline impact the technology you're using? I mean, tech advancements come pretty fast. So what factors help you choose which tech to use and which tech to set aside for the next project?
That was exactly a discussion that we had as soon as we signed the contract because the technology is expected to be up and running with all the support necessary for its operation for 30 years. So what we did is to select among our portfolio of solutions the one that had less chance of being obsolete. We knew, for example, the big problem is the electronic components of those products because they are electronic equipment. This kind of components that we could easily replace if they go obsolete, or for some of them, we already know that they are not going to be obsolete in the next years. We had agreement with our suppliers. So that's the first thing that we did. The second one is that we had an agreement with the customer to, as soon if you needed to update the technology in the long run during the period, according to customer requirements, we guarantee that we can do that.
What are some of the top skills, whether that's the technical skills or, soft or power skills, as PMI calls them, that help you the most in delivering this type of project?
In the energy project, works are subject to several EHS risks throughout the life cycle of the project, environment, health, and safety. Project managers must be aware of it. It's a big responsibility. So first skill would be, I would say, EHS management. Energy sector is highly regulated, and we must respect that regulations are laws, okay? So what is the problem with the regulations? They change. Sometimes they are hard to meet, so the risk of scope change because of the regulations and some technological barrier that may come from these regulations change. So the second skill I would say would be scope and technology management. Besides that, Hannah, maybe complexity of stakeholders. As I mentioned, there is not only one customer. We have governments, we have regulators, we have national grid operators, we have society that's looking at it. So communication and stakeholder management is a top priority for the project manager. Another one that is very important, we need to go fast, right? There is a countdown to this cleaner energy implementation. We need to go on a fast pace to try to achieve what we must achieve to meet the clean energy goals.
How do you see the energy industry and energy industry teams using technology in the future? What types of tech are you expecting to become more common, and how is that going to impact the global carbon neutral ambitions?
I see a stronger pace of digitalization and adapting new IT technologies. Normally, we lag IT. Okay, IT goes really faster than energy in terms of technology. We try to keep the pace. Today, we rely a lot on hardware. Okay, so by digitalization, we start using software as a service for substation solutions. Because of digitalization, I see also cloud and centralized solutions that depend on networks, also like LTE technology for radio communication, like cellular data, mobile data communication, industrial application. And what I see also, I talked about the PMU, the phasor measurement units, that will bring us data. And by doing that data, Hannah, I think that we are going to improve a lot analytics and data exploitation. That is very important to fine-tune our systems and for planning future infrastructure along with the governments. Maybe people say, and what about AI and LLMs?
You already knew. You knew my next question.
For the operation part, I don't see AI or LLMs technology like operating power plants or the electrical grid. Okay, I don't see it on the daily operation or daily protection system for the core operation. And why that? They are critical infrastructure or very critical operations. And in those sectors, whenever there is an unexpected situation, an error or something happens, really need to know what happens in order to guarantee that it doesn't happen again. When we have a blackout, we work with the governments to explain what happens. If you use AI, by definition, it's very difficult to find the root cause. Why? Because AI, it's like a black box. These LLMs, nobody knows, even the AI engineers, what is happening on these tens of billions of parameters that we have on those LLMs algorithms. But that's not the whole story, because we can, and we are using LLMs in other situations. We are using LLMs for data analytics to improve design and optimize solutions. We may use also solutions designed with the support of LLMs. That's we are doing also. We leverage that to expedite solutions. But in the energy sector, Hannah, the most important thing is everything must be validated by humans before going to production.
Thiago, this has been a fantastic conversation. I want to just wrap up with, why are you passionate about working to generate cleaner energy? What effect do you hope that your efforts and your team's efforts will have in the energy sector?
I'm really proud and passionate about that energy sector. For me, it means a lot, especially because the magnitude of the projects that we work on and how that impact society and change people's lives and the economy. And having a leading role on these projects that contribute to, I would say, more sustainable planet is really rewarding, because I know that most people cares about it and will benefit from it.
Thanks for listening to Projectified. Like what you heard? Subscribe to the show on your favorite podcast platform and leave us a rating or review. Your feedback matters a lot. It helps us get the support we need to continue making this show. And be sure to visit us online at pmi.org/podcast, where you'll find the full transcripts for episodes, as well as links to related content like useful tools and templates, the latest research reports, and more. Catch you next time.